Okay, we're going to finish this handout. This is H12B. This is the continuation of this handout, H12A, H12B. Okay, so H12B. Okay, you could read this. It gives an example of when we use components of vector quantities. Okay, so let's look at the investigation. Let theta be the angle between two non-zero vectors A and B. Think of the direction of B as being along one of the axes. Okay, so B is going this direction. Okay, show that the component of A in the direction B can be written as this. Okay, so the component of A in the direction of B. Okay, so I'm trying to figure out this part of here. Okay, now just forget about this part. Just focus on this part right here. Okay, so I want to figure out this part right here. The component of A in the direction V. So this part here of my vector. We've got this, we've got an angle, and we've got magnitude, and we're going to figure out this part here so we can write it as a column vector. Okay, so to figure out this value, I can go back to SOHCAHTOA, and with this angle, this is adjacent, and we know this is the hypotenuse. So if I've got adjacent and hypotenuse, then I'm going to be using cosine, aren't I? So we can write this as cosine x, or cosine theta, equals adjacent over hypotenuse, right? So this gives us cosine theta equals, let's just call it x over a. And so we want the component of A in the direction B. Direction of B is x, right? So I can rewrite this. I can cross multiply, and I can get x equals a cosine theta. And we're going to put in absolute value because they did. But absolute value means that this is always going to be a positive value. Okay, so there, we just showed this. Okay. Find a similar expression for the component of A perpendicular to B. So the component of A perpendicular to B. So we're trying to figure out this value here. So I'm going to call that y, because we think of y going up and down, right? So this here is opposite. This here is the hypotenuse. We're trying to figure out component of A going this direction. So going that direction is y. And so if I've got opposite and hypotenuse, I'm going to be using sine. So I can call this sine theta equals opposite over hypotenuse, right? So I can think of this as sine theta equals y over a, and I could put this over 1 and cross multiply, and then I end up with y equals a sine theta. And just like before, we're going to put this, because that's always going to be positive. Okay. Okay, rewrite the expression for the component of A and the B in terms of the scalar product here. So in H3L chapter, we use the scalar product formula, and we've got A dot B is equal to the magnitude of A times the magnitude of B cosine theta. Okay, so and let's see, and we even have that in our formula packet. So you don't need to memorize that. So, and we're going to rewrite an expression, the component A in the direction B. The component A in the direction of B is this, right? So if we're going to rewrite the expression for the component A in the direction B in terms of the scalar product of A and B, so we're going to rewrite the component of A in the direction B in terms of the scalar product. So basically I'm going to use this equation, and I want it to have this equal to something. So to get this, I have to divide both sides by B. So we're going to divide both sides by B, absolute value of B, and then I get A dot B divided by the absolute value of B, and that's going to give me A cosine theta, right? I just took this here and divided both sides by absolute value of B, and I got this. Okay, and okay, rewrite the expression for the component of A perpendicular to B. So same process. We're trying to rearrange it to look like this. Now, if it's perpendicular, then we know the cross product. The magnitude of the cross product is equal to A B cosine theta. So this is the cross product vector, right? Because it's perpendicular, we got to use the cross product. And so same, just like we did over here, we're going to divide both sides by the magnitude of B, and then I end up with A cosine theta equals the cross product of A, B divided by B. Okay. Okay, and we're going to use these two relationships to help us with our next part here. Okay, so this gives us in the direction. This gives us in the direction of B, or our x value of our column matrix. This gives us the y value of our column matrix. In fact, I'm going to write that down. This is the x value of the column matrix This is the y value of the column matrix. Okay. All right, so let's do our first one. Hence, find the components of this in the direction of this. Okay, so we're going to call this first one matrix A. And I'm going to call this matrix B. Okay, so if it's in the direction of this, then we're going to use A dot B over the magnitude of B. A dot B over the magnitude of B. Right, that's what we did. So we end up with so 1, 2, 1 dot negative 3, 4, 0 gives us 1 times negative 3 plus 2 times 4 plus 1 times 0, which is equal to negative 3 plus 4, which is equal to 5. Okay. Magnitude of B is equal to square root of negative 3 squared plus 4 squared plus 0 squared. And that's going to give me the square root of 9 plus 16. 9 plus 16 is 25. Square root of 25, that's also equal to 5. Okay, so using this information here, I can get 5, and the magnitude of B is also 5. So the component of this in this direction is 1. Okay? So for question B, perpendicular to this, okay, so once again, this is vector B, this is vector A. If we're going to make it perpendicular, we're going to use this relationship, A cross B, over the magnitude of B. So A cross B. So we first need to figure out the cross product, and then we have to find the magnitude of that cross product. So cross product of 1, 2, 1 and negative 3, 4, 0 is going to give me 2 times 0 minus 1 times 4. And then the middle one is 1 times negative 3 minus 1 times 0. And the bottom one's going to be 1 times 4 minus 2 times negative 3. And then that should simplify to give us negative 4, negative 3, and positive 10. Okay? So now I need to find the magnitude of negative 4, negative 3, 10. Right? So to figure out that magnitude, we get negative 4 squared plus negative 3 squared plus 10 squared, and that simplifies to 16 plus 9 plus 10 gives me 125. Okay, And so now we're going to apply the A cross B divided by the magnitude of B, which is A cross B is the square root of 125. Magnitude of B, we did that over here, which is 5. And we simplify that on our calculator, and we get 2.24. Okay, so this is the component of this perpendicular to that. Okay, so the next part is, so how do we find the components of a vector A acting parallel to a vector and perpendicular? So we need the scalar and vector products can be used to find the components of the vectors acting parallel and perpendicular to B. Maybe we'll hit pause and copy this down. And on the next page, basically what we just found out is that A dot B over the magnitude gives us the component in the B direction. We can call this the X direction. It doesn't have to be the X direction, but in the B direction, we'll just call it the B direction. And we can call this the Y direction. The reason they say in the B direction is because it could be tilted some direction, and it doesn't necessarily have to be X and Y. It doesn't have to be X and Y. It could be tilted and whatever, but just think of it that way. That's helpful. Okay, so let's do this first example, and then maybe I'll finish this handout on a separate recording. Okay, so write down the velocity of the wind as a column vector. Okay. The sailboat is traveling at a bearing of 45 degrees, and the wind is blowing at a velocity of 40 kilometers per hour from a direction of this. Okay, so the boat has the bearing of 45. The wind has a bearing of 200 degrees. So the first thing I do, so here's north, and it's blowing at 200 degrees. So it's blowing this way. So it's blowing towards this direction. Okay, this would be 180 right from here to here, so 200 degrees. So write down the velocity of the wind as a column vector. So so if it's blowing from that means it's instead of going that direction, it's blowing from that angle. Okay, so I'm going to draw a triangle here. Okay, and it's got a velocity speed of 40. So my magnitude there is 40 kilometers per hour. Okay, so from here to here is 180. So this here has to be 20 degrees. Okay, so I'm going to rewrite this. If that's 20 degrees, if this is 20, this here has to be 70 degrees, because they all have to add up to 180, right? And if that's 90, okay. This is 40. And so in the x direction, I'm dealing with adjacent and the hypotenuse. So just to help me out, so TOA. Okay, so if I'm working with adjacent and hypotenuse, I'm going to use cosine. So I can write this as, I'm going to call that x. Okay, so cosine 70 degrees equals adjacent over hypotenuse, so x over 40. Okay, and so if I want to rewrite this in my x direction, I could cross multiply and I get x equals 40 cosine 70 degrees. Okay, in the y direction, we're dealing with opposite and hypotenuse. And if I'm dealing with opposite and hypotenuse, we're going to use sine. So I'm going to write sine 70 degrees equals opposite over hypotenuse equals y over 40. And if I cross multiply, then I can say y equals 40 sine 70. Okay, so I'm trying to write this in a column vector. Write down the velocity of the wind in the column vector. So now I've got my x component and my y component. So my wind is going to be equal to 40 cosine 70 and 40 sine 70. And that simplifies in the calculator. That simplifies to 13.7 over 37.6. Okay, so that's the answer for A, the velocity of the wind as a column vector. Question B. Find the component of the velocity of the wind in the same direction as the path of the boat. Hold on. Okay, so next, so find the component of the velocity of the wind in the same direction as the path of the boat. So the boat is traveling 45 degrees. So, so we've got the wind, which is vector A, which we know is 13.7 and 37.6. The boat, we can call that vector B, which if it's going at a bearing of 45 degrees, I know it's this. Okay, so we want to find the component of the velocity of the wind in the same direction as the boat. So if it's in the same direction of the boat, it's not perpendicular. If it's in the same direction, same direction, I'm going to be using the dot product. So A dot B over the magnitude of B, right? If it's in the same direction. I would be using this one here if it's perpendicular. Okay, so if it's in the same direction, let's figure this out. So 13.7 over 37.6 dot 1. So that gives me 13.7 times 1 plus 37.6 times 1. And that should give me 51.3. Okay, and the magnitude of B is the square root of 1 squared plus 1 squared, which is the square root of 2. And now we can say A dot B over magnitude of B is equal to 51.3 divided by the square root of 2. So that answer divided by square root of 2, and we get 36.3 kilometers per hour, and that is the component of the velocity of the wind in the same direction as the path of B. Okay, and the other examples I will do in a separate video.